Hi there and welcome to another video from Hegarty Maths. It's Mr. Arnold here, and in this video I'm going to focus on some core maths techniques. Namely, we're going to focus on quadratics and inequalities, and although it's based on the material you need for A-level maths, it is applicable to most other maths modules. Okay, now before we crack on and do some examples about how to solve various different types of inequalities, let's just remind ourselves of something. Suppose I was asked to solve the inequality negative 2x was less than 8. Well, normally if I was solving this like an equation, I would divide both sides by negative 2 and we'd say x would be less than negative 4. So let's see if that works. Suppose I choose a value that's less than negative 4 for x. Let's choose x equal to, say, negative 5. And let's see what happens when I substitute back in here. So if I do negative 2 times negative 5, we get 10. And 10 most certainly is not less than 8. So something has gone wrong here. It's an important feature that when we're dealing with inequalities, and if we have to multiply or divide by a negative number, both sides should I say, multiply or divide both sides of the inequality by a negative number, we need to change the inequality. So, negative 2x is less than 8. Dividing both sides by negative 2, we get x should be greater than negative 4. Let's see what happens here. I need to choose any value that's bigger than negative 4 for x. Suppose we choose x equal to negative 3. Let's see what happens. We get negative 2 times negative 3, which would give me positive 6, and positive 6 is indeed less than 8. And you'll find any value that's bigger than negative 4 will satisfy the inequality. So, let's just summarize that. Quick note, quick reminder, if you multiply or divide by a negative number, you must change the inequality. Divide both sides, should I say. We must change the inequality. Okay, so let's have a look at the first example here. I need to solve this inequality just like I would an equation. Expand the brackets. So we're going to expand first, and we get 6 plus 2x greater than or equal to 24 subtract 4x. Next thing I'm going to do is I'm going to add 4x to both sides. And in the same move, I'm also going to subtract 6 from both sides. So let's add 4x to this side, and we get 6x. And adding the 4x over here makes this disappear. And subtracting 6 from this side leaves me with 0, and subtracting 6 from this side leaves me with 18. So 6x must be greater than or equal to 18. And then finally, we're going to divide both sides by 6. So we get x must be greater than or equal to 3. So any value that's bigger than or equal to 3 will satisfy our inequality. Let's try another one. So, I need to solve this inequality. Again, let's expand. You may want to pause the video and have a crack yourself. Let's see, 4 times 5 is 20. 4 times negative 2x is negative 8x. Which is greater than 3 times 7 is 21. 3 times negative 2x, negative 6x. Now this time I'm going to add 6x to both sides, and then I'm going to also subtract 20 from both sides. So adding 6x to both sides, we get negative 2x here, and this 6x disappears. And we're subtracting 20 from the left hand side, so I must subtract it from the right, which gives me 1. Negative 2x is greater than 1, so here's a chance to put the reminder into action, dividing both sides by negative 2, which means that x must be, dividing by a negative number, change the inequality, must be less than negative 1/2. So if it's greater than, you switch it to less than. If it's less than or equal to, you switch it to greater than or equal to, etc. So any value which is smaller than negative 1/2 will satisfy this inequality. Okay, let's take it up a step now. So suppose we're trying to solve a quadratic inequality. Now I'm going to need some skills from before. So we want to find a set of values for x which satisfy this inequality here. The first skill we're going to need is we're going to need to factorize. So what we do is we consider the quadratic equal to 0, because that's a little bit easier to manage. Plus 3 equal to 0. So we're going to factorize this now, and we get x, two numbers that multiply to give negative 3 but add to give negative 4, and we get our positive 3 but add to give negative 4, positive 3 and negative 3 and negative 1. So if I multiply negative 3 times negative 1, I get positive 3, and adding them together I get negative 4. That's equal 0, which means that x subtract 3 equals 0, or x subtract 1 equals 0, which means that x must be equal to 3, or x must be equal to 1. Okay, so we've solved the quadratic equal to 0. Next thing I'd like to do is sketch the quadratic. So a quick sketch so I can get my head around what the solutions might be. Okay, so the solutions are 1 and 3, so 1 and 3. And also I should be considering the shape of the graph. Well, it is a quadratic, which means it's a U or an N shape. The coefficient of x squared is positive, which means it must be a U shape. So we're going to get something like this. And that would pass through 3 if I could draw it properly. Let me try and cheat here a bit. There we go. Okay, so the graph comes down, passes through 1, and then comes back up and passes through 3. Now the question is, where is the graph less than 0? So let's get a highlighter pen out here. Let's make it a little bit thinner. Okay, so where is it less than 0? Well, we can see it's less than 0 all around here. This region in here is less than 0. And what values of x make it less than 0? Well, we can see when x is bigger than 1, we'll have a value that's less than 0, and when x is less than 3. So, when x is bigger than 1, and when x is less than 3, that would satisfy this inequality. Let's see if we can make it even better. Well, that means that 1 would be less than x, but x would be less than 3. So any value which is bigger than 1 but less than 3 will satisfy the inequality. Yeah, let's see another one. This time, same idea. We're going to consider the quadratic equal to 0. So 2x squared subtract 5x subtract 3 is equal to 0. We're going to factorize. Coefficient of x squared is bigger than 1. So we're going to do 2 times negative 3 to get negative 6. That's my target. So, two numbers that multiply to make negative 6 but add to make negative 5. Leave the 2x squared alone and leave the negative 3 alone. And what we're going to do is we're going to split the negative 5x into two things, such that they multiply to make negative 6 but add to make negative 5. So I'm thinking negative 6x plus 1x would give me the negative 5x. If I do negative 6 times 1, I get negative 6, and if I add negative 6 and 1, I get negative 5. Next thing I'm going to do is factorize it. So we're doing this by grouping. So if I look at this, 2x squared subtract 6x, I can factor out 2x. Factoring out 2x, we get x subtract 3. And then what have we got left over here? We've got left with x subtract 3. And that's actually one lot of x subtract 3. That's equal to 0. What's common to both? what's common to this and this? Well, x subtract 3 is, so I can factor that out. So we get x subtract 3, and what's left? 2x plus the 1. And hence it's been factorised. Now you might have a different way of factorising it, that's fine, use whichever method you're comfortable with. Okay, so x subtract 3 must be equal to 0, and 2x plus 1 must be equal to 0. Solving this linear equation we get x equals 3, and solving this one we get x equals negative 1/2. So we've solved it equal to 0. Next job, sketch the quadratic. And once again, we have to consider the shape of the graph. Well, it's positive 2x squared, which means it's a U-shaped graph. So it's going to pass through x equals negative 1/2, and it's going to pass through x equals 3. So then we sketch the quadratic. It will look something like this. I know it's a U-shaped graph. It's going to come down, and then it's going to pass back up through 3. So that's what the graph looks like. And then finally, I want to know, where is the graph greater than or equal to 0? So, take the highlighter out again. Where is it bigger than 0? Well, here the graph is bigger than 0. And here the graph is bigger than 0. So what values of x will make it bigger than or equal to 0? If the value of x is less than or equal to negative 1/2, so if the x value goes in this direction, we get a value that's bigger than 0. And if the x value goes in this direction, it's bigger than 0. So where x is greater than or equal to 3. Unfortunately, we can't actually split this or we can't write this as one inequality. We'll just have to leave it at that. And they are our solutions. So for values of x that are less than or equal to negative 1/2, and x greater than or equal to 3. Okay, number 4. Okay, so I need to find a set of values for x for which this is greater than or equal to 0. Once again, consider the function equal to 0. 2 subtract x, subtract 3x squared, equal to 0. Now I'm going to make my life a whole lot easier by multiplying everything by negative 1, and I get this. So we're multiplying by negative 1. I'm allowed to do that because it's equal to 0. So we get 3x squared plus x subtract 2 must be equal to 0. Now I'm going to get my target number, so I'm going to factorize here. This is how I do it. 3 times negative 2, negative 6. Okay, two numbers that multiply to give negative 6 but add to give positive 1. Leave the 3x squared and the negative 2. So two numbers that add to give me a positive 1 would be a 3 subtract 2. So 3 times negative 2 would give me negative 6, and 3x subtract 2x is x. Okay, and that's equal to 0. So we're going to group these now. I'm going to factorize this, and then separately I'm going to factorize this. Okay, so out of these two I can factor out 3x, and that leaves me with x plus 1. And then over here I can factor out negative 2, and that will give me x plus 1, and that works out wonderfully. So what's common to both these now? I've got x plus 1 in both, so that can be factored out. So we get x plus 1, and what's that multiplied by? 3x subtract 2. and hence it's been factorised. Now you might have another method, choose whichever one you like to use. Okay, which means x equals -1. Over here we'd have 3x equals 2, which means x equals 2/3. Okay, so we've been factorised there. Right, next thing I'm going to do is sketch the quadratic. Okay, now what I've looked at is a reflection of the original quadratic when I factorised here. That would be a U-shaped graph, but this guy here is actually going to be an N-shaped graph because it's -3x squared. The roots are still going to be the same. The roots are still -1, which is around about here, and 2/3, which is, say, around about here, 2/3. So instead of doing a U-shaped graph, which is what I would have if I looked at this, I need to look at the reflection of that, which would be an N-shaped graph. However, as I said, the roots are the same. So it comes up and then passes down through here, something like that. Okay, now I'm asked the question, where is this graph greater than or equal to 0? Let's go for the highlighter. It's greater than or equal to 0 all along here. This is all bigger than 0, isn't it? So what values of x? Well, if x is greater than or equal to -1 or less than or equal to 2/3. So when x is greater than or equal to -1, or when x is less than or equal to 2/3. So any value of x in here makes the graph greater than or equal to 0. Okay, so now we should be able to put this into one inequality, and that's where -1 is less than or equal to x, which is less than or equal to 2/3. And there's a set of values of x which satisfy the inequality. Okay, last one here. So same idea again, find a set of values for x. First thing we're going to do, expand the brackets. We get 26 plus 4x less than 6 times 1 is 6, 6 times -x, -6x, x times 1 is x, and x times -x, -x squared. Okay, let's take everything to the right hand side because that's where my x squared term is. Subtracting 26 from both sides gives me -20. Subtracting 4x from this, we get -9x and -x squared. Okay, let's write things the other way around just so that it looks the way we normally do. So we get -x squared, subtract 9x, subtract 20 is greater than 0. Okay, now let's consider it equal to 0. So consider the quadratic equal to 0. So -x squared, subtract 9x, subtract 20 is, I was about to write greater than down again, it's equal to 0. And then what we can do here is we can multiply everything by -1. So we get x squared plus 9x plus 20 equals 0. Factorising here should be straightforward. X plus 5 and x plus 4 equal to 0, which means that x must be equal to -5 and x must be equal to -4. Okay, so let's sketch what we have. So we get, say, -5 here and -4, if you will. Now this quadratic, which is what we had, after we expanded and tidied things up, I haven't broken any rules here. It's a negative quadratic, and we want to know where it's greater than 0. Negative quadratic, which means it has this type of shape. It's an N shape. So it'll come up like that and then down like that. And we want to know where is it greater than or equal to 0. Well, all these values in here are greater than 0, not greater than or equal to, should I say. So any value of x that's bigger than negative 5, so a value of x that's bigger than negative 5, or a value of x that's less than negative 4. So, which means that we can combine this into one. We say that negative 5 must be less than x, but x in turn must be less than negative 4. And any value in there will satisfy the original inequality. Okay, a couple more examples to do, just based around quadratics. And this kind of links back to our earlier videos on the discriminant. So I need to find a set of values for k such that this quadratic has equal roots. We must remember, if it's got equal roots, that means that b squared subtract 4ac must be equal to 0. So that's what we're looking for. So we let so a equals 1, b equals negative 6, and c equals k. And we're going to let b squared subtract 4ac be equal to 0. So let's substitute now. B squared is going to be negative 6 squared, subtract 4 times a, which is 1, times c, which is k, be equal to 0. Which implies negative 6 squared, 36, subtract 4 times 1 times k, 4k, must be equal to 0, which means that negative 4k equals negative 36, which means that k must be equal to 9, dividing both sides by negative 4. So if k is 9, then this quadratic here has equal roots. Another one of a similar type, find a set of values for k such that this quadratic here has no real roots. Well, if it's got no real roots, that means that b squared minus 4ac must be less than 0. If it's less than 0, we're trying to take the square root of a negative number, and that's quite tricky to do unless you have an understanding of complex numbers, which is not on the course. So, in this case, a must equal 1, coefficient of x squared is 1, b will equal k, and c will equal negative 3k. So here's what we're going to do. We're going to let b squared subtract 4ac be less than 0. And then we substitute. b is k, so we get k squared subtract 4 times a, which is 1, times c, which is negative 3k. And that must be less than 0. Let's see if we can tidy this up. So we get k squared subtract negative 4 times negative 3 will be positive 12k, must be less than 0. Okay, so k squared plus 12k must be less than 0, which implies, and I'm going to factorize here, k into k plus 12 must be less than 0. Okay, let's consider this equal to 0. So consider it equal to 0, k times k plus 12 equal to 0, which would suggest that k equals 0 or k equals negative 12. Okay. Now what we could do is we could sketch this really quickly. If k was 0, it would be here, and k being negative 12 somewhere over here. This is a positive quadratic, which means it follows this type of shape. Like that. And where is this quadratic less than 0? Well, let's get the highlighter out. All these values are less than 0. That means any value of k, which is bigger than negative 12 but less than 0, will satisfy it. So, any value, if k was less than 0, that works, or if k is bigger than negative 12, that works. So, let's write it down formally. That means negative 12 must be less than k, which must in turn be less than 0. So any value between negative 12 and 0 will actually give me a quadratic which has no real roots. Okay, final question here. So we need to find a set of values of k such that this quadratic has real roots, and that means that b squared minus 4ac must be bigger than 0. Okay, same idea applies. So a is going to be 3, b will be k, and c equals negative k plus 3. All this bit is the constant. I'm going to rewrite that as 3 subtract k. Okay, so we're letting b squared minus 4ac be equal to 0. So b squared minus 4ac be greater than 0, and then substitute in, we get k squared minus 4 times a, which is 3, times c, which is 3, minus k must be bigger than 0. Okay, and what we're going to do is now expand out this bracket, and we get negative 12 times 3 subtract k must be bigger than 0. And then expand this bracket out, so k squared minus 36 plus 12k must be greater than 0. And I'm just going to rewrite it in a form that I'm used to. So k squared plus 12k subtract 36 must be bigger than 0. Okay, now let's consider it equal to 0. So k squared plus 12k subtract 36 equal to 0. Now a little bit of thought, I realised that I can't factorise this a traditional way. You might use a quadratic formula. I'm going to complete the square. So k plus half the coefficient in here, which is 6. Stick the squared symbol outside. That's going to give me a positive 36, which I don't want, so subtract that away. And then we still have the negative 36. So if you're a little bit unsure about that, do look at my video on completing the square. Okay, so we get k plus 6 to be squared, subtract 72 equals 0. Adding 72 to both sides, k plus 6 squared equals 72. Take the square root of both sides, k plus 6 must equal plus or minus the square root of 72. Now we're going to use our skill with surds, so k plus 6 must equal plus or minus square root of 72 is the square root of 36 times 2. 36 times 2, which is plus or minus 6 root 2. So k plus 6 equals plus or minus 6 root 2, which means that k equals 6 root 2 subtract 6, or negative 6 subtract 6 root 2. Okay, lots going on there. Let's see if we can finally finish it off. So I'm going to start by sketching the graph just to see what values of k I'm going to use. Let's go back up to my original quadratic, which is here. K squared plus 12k subtract 36 greater than 0. In fact, let me copy that part down. Okay. So that was the original quadratic. These are our solutions. Now let me have a think about this. 6 root 2 subtract 6. Well, root 2 is bigger than 1. So 6 times something that's bigger than 1 is going to give me an answer that's bigger than 6, which means that this part is positive. I'll call that 6 root 2 subtract 6. Negative 6 subtract 6 root 2 must be negative. Negative 6 subtract 6 root 2 must be negative. And I know that the quadratic is positive. So it's a U-shaped graph, which means it goes down like this and then up like this. Where is the graph bigger than 0? It's going to be here and here. So any value that's less than this, and any value of k that's greater than this. So when k is less than negative 6 subtract 6 root 2, and when k is greater than 6 root 2 subtract 6. And that's it from me. Hopefully you found the video useful. A lot going on there, a lot of skills required, but as I said, hopefully you did find it useful, and I'll be back again with another video soon. All the best.